In late May 2025, one decision made in Washington nearly stopped China's entire commercial aviation program dead in its tracks. No missiles, no sanctions on TV. Just a quiet notice from the US Department of Commerce, and suddenly the most important production line in Chinese aviation went silent. The target was a single engine, the CFM LEAP-1C, built by CFM International, a joint venture between America's GE Aerospace and France's Safran. That one engine powers every single C919 flying today, and China does not make it. Here's why that matters so much. The C919 is real. It's not a prototype sitting in a hangar somewhere. It's flying right now with Air China, China Eastern, and China Southern, carrying real passengers on real routes. By May 2025, it had been in commercial service for exactly 2 years, with 18 aircraft in the fleet and millions of passenger trips already logged. On paper, it looks like proof that China can build a full-size passenger jet from scratch. But look under the wing, and the story changes completely. The engine, arguably the single hardest part of any airplane to build, comes from Ohio and France, not Shanghai. Think about what a jet engine actually has to do. It's a machine roughly the size of a delivery van, spinning at thousands of RPM, sucking in air and compressing it until it's hotter than 1,000 degrees Celsius. Then blasting it out the back with enough force to drag a fully loaded airliner across an ocean. Only a small handful of companies on the entire planet know how to build one that regulators trust with human lives. And that one component, the LEAP-1C, makes up close to 30% of the total cost of a C919. Nearly a third of the plane's price tag, and none of it is Chinese. So when the US Department of Commerce suspended those export licenses in late May 2025, it wasn't just the engine that got hit. Honeywell avionics was suspended too. Collins Aerospace flight control components were suspended too. All American, all essential, all frozen at once. For roughly 5 to 6 weeks, COMAC's factory floor had airframes with no engines to bolt onto them. Deliveries that airlines were counting on simply didn't happen. That message was simple. If one country can shut down your national aircraft program with a single phone call, you don't actually control your own aviation industry. You're renting it. China's answer already existed before the crisis. It just wasn't a priority yet. It's called the CJ1000A, built by the Aero Engine Corporation of China, known as ACC, through its Shanghai-based division. And the goal from day one was deliberate. Build an engine that can drop straight into the same mounting points as the LEAP-1C. No redesigned wing, no new airframe certification. The numbers back that up almost exactly. The CJ1000A measures 1.95 meters in diameter and 3.29 meters in length. The LEAP-1C measures 1.98 meters in diameter and 3.32 meters in length. That's not a coincidence, that's the entire point. On thrust, the CJ1000A is designed to produce around 28,200 pounds of force, enough to match what the C919 actually needs. With a higher thrust variant, the CJ1000B, rated at roughly 29,500 pounds for future extended range versions. Inside, it isn't a copy-paste of old technology either. It uses 18 hollow titanium fan blades, a 10-stage high-pressure compressor, and a combustor built with 3D printed fuel nozzles, manufacturing techniques that didn't even exist when the engine it's replacing was first designed. Has it actually flown? Yes, but not yet on a C919. Flight testing began back in March 2023 on a modified Xianwei-20, China's massive military cargo plane, used as a flying test rig so engineers can gather real air, real speed, real stress data before anyone trusts the engine near paying passengers. In March 2025, Shi Jianzhong, honorary president of the Shanghai Society of Aeronautics and a former deputy general manager at COMAC. That's someone who used to run part of this program. But here's where the hype has to meet reality. Flying on a test rig is not the same as being certified to carry passengers every single day for the next 20 years. Certifying a commercial jet engine means proving it survives bird strikes, ice, blade failures, engine restarts at altitude, extreme heat, extreme cold, hundreds of individual test scenarios that regulators verify one by one. According to aviation analyst Maya Patel of OG Aviation, speaking in January 2026, Chinese certification of the CJ1000A is realistically expected in 2027 or 2028, with mass production not arriving until around 2030. That means an engine that was originally supposed to enter service back in 2021 is now running roughly 8 to 9 years behind its original schedule. Not because anyone gave up, but because commercial aviation simply does not let you cut corners on the timeline. And even once the CJ1000A is certified in China, that doesn't open the doors to Europe or the United States. FAR and EASA certification for a Chinese-built engine is a separate, far longer, far more political process, one that could stretch well beyond this decade. So don't expect a CJ1000A powered C919 landing at Heathrow or JFK anytime soon. That was never really the target anyway. The real target is everywhere else. More than 150 countries have deepened economic ties with China through the Belt and Road Initiative, and airlines in those markets aren't asking whether an aircraft has FAR approval. They're asking about price, fuel efficiency, and maintenance support. A C919 powered by a fully domestic Chinese engine removes the one risk that leasing companies in Singapore, Dublin, and Bermuda have been nervous about from the start, the risk that Washington could ground the fleet with a single regulatory decision. So here's where this actually lands. China just built a brand new engine for its C919, and it's not a science project anymore, it's national policy. It has flown. It has reportedly outperformed expectations. And if the 2027 to 2030 timeline holds, the lever that Washington pulled in May 2025 disappears for good. The only question left is whether the rest of the world's airline market is still wide open by the time that engine is finally ready to fly with passengers on board. Japan just made one of the boldest moves in modern tech history, and China's answer left the world stunned. In September 2025, Tokyo quietly added 110 Chinese companies to its export blacklist. Not random firms companies working on semiconductors, AI chips, quantum computing, and even the specialized cooling systems used in advanced chip factories. Analysts called it one of the most aggressive tech sanctions Japan has ever issued, with some saying it went further than Washington's own restrictions. But Japan wasn't acting alone. This escalation had been building for years. Back in July 2023, Japan first restricted 23 types of semiconductor equipment headed to China. Then, in April 2024, it added 21 more items, including advanced quantum computing equipment. By February 2025, the total number of blacklisted Chinese entities hit roughly 110. Japan was following the same playbook as the United States, which had already added more than 15,000 Chinese companies to its own restricted trade list since 2022. Here's the problem: Japan picked this fight while sitting on a massive weakness it never fully addressed. In the 1980s and 1990s, Japan dominated global chip making. Toshiba, Hitachi, and NEX controlled over 50% of the world's semiconductor market. That era is long gone. Today, no Japanese foundry can mass-produce a 7-nanometer chip. Meanwhile, China's SMIC has already completed trial production of 7-nanometer samples, technically surpassing where Japan stands right now. Japan tried to fight back with Rapidus, a government-backed project pledged $6 billion, aiming for 2-nanometer chip technology. But Rapidus depends heavily on core technology from America's IBM, and its pilot production isn't expected until 2028, putting Japan roughly 5 years behind TSMC and Samsung. The cracks were already showing in the supply chain before this fight even started. Take 6-inch silicon carbide wafers before 2020, a single wafer cost as much as $1,300. Once Chinese manufacturers scaled up mass production, prices crashed to around $800, a nearly 40% drop. Japan's Rome Corporation was forced to slash its own prices to $900 just to stay in the game. Then there's JS Foundry, a Japanese chipmaker supplying MOSFET chips for air conditioners and refrigerators. Those chips once sold for 40,000 yen per 1,000 units. When Chinese competitors matched the specs, prices collapsed to 18,000 yen, a 55% drop. JS Foundry lost so many orders it declared bankruptcy in 2023. So Japan needed leverage to slow China down. And China's response was surgical. In July 2023, Beijing restricted gallium and germanium. In October 2023, it added high-purity graphite. In August 2024, antimony got added to the list. By December 2024, China fully banned exports of gallium, germanium, antimony, and super-hard materials to the United States. Then in April 2025, China expanded controls to 7 medium and heavy rare earths: samarium, gadolinium, terbium, dysprosium, lutetium, scandium, and yttrium. Here's why that's devastating for Japan. Historically, about 90% of Japan's rare earth supply came from China. Even after spending over $1.1 billion trying to diversify since a crisis in 2010, Japan's dependence only dropped to somewhere between 58% and 65% by 2024. Japan still imports over 8,300 tons of rare earths every year. This isn't the first time China has shown it will do this. Back in 2010, after a maritime collision near the Senkaku Islands, China cut off rare earth exports to Japan. Prices spiked tenfold within a year. That memory is exactly why Japanese executives, including at Toyota, reportedly warned Tokyo officials privately that pushing too hard on chips could trigger the same kind of retaliation on materials. But the story didn't stop with Japan, it went global. On October 9, 2025, China's Ministry of Commerce dropped a bombshell aimed straight at ASML, the Dutch company that makes the only machines on Earth capable of producing the most advanced computer chips, extreme ultraviolet lithography systems. The new rule was brutal in its simplicity: any product containing just 1% or more of Chinese origin rare earth material now needs a Chinese export license, even if that product is built entirely outside China. Every single UV machine, machines that cost up to $200 million each, depends on rare earth components that essentially can't be sourced anywhere else at the purity required. The cerium oxide used to polish ASML's lenses needs 99% purity, a standard only Chinese refineries hit consistently American mines only reach around 92%. According to ASML's own CFO, Roger Dawson, the company only has enough rare earth inventory to last a couple of months. After that, monthly output could fall by 15 to 20 machines, putting more than $3 billion a year at risk, and that's before counting the ripple effect on TSMC, Samsung, Intel, and every chip that ends up inside an Apple, Nvidia, AMD, or Qualcomm product. Then came the twist everyone was waiting for. On October 30, 2025, President Trump and President Xi Jinping met in Busan, South Korea, and struck a truce. China agreed to suspend the sweeping October 9th controls for 1 year, until November 10, 2026, and issue general licenses for rare earths, gallium, germanium, antimony, and graphite. Zoom out, and the numbers get even more staggering. China controls roughly 89 to 94% of global rare earth permanent magnet production and refines close to 90% of the world's rare earths overall. The International Energy Agency says China holds an average 70% market share across 19 out of 20 critical strategic minerals. In response, the US Department of Defense invested $400 million into MP Materials, becoming the largest shareholder in America's only operating rare earth mine, with a 10-year price floor of $110 per kilogram. The G7 has agreed no single country should supply more than 60% of any nation's rare earth imports by 2030. Countries like Malaysia and Australia are racing to build alternative supply chains too. But even Japan, the most committed country in the world on this issue, spending 15 years and over $1.1 billion, only managed to cut its dependence from 90% down to around 50 to 65%. That's the real lesson here.
In May 2026, the United States government did something almost nobody thought was survivable. It put Huawei on the entity list, cutting the company off from Android, from Google mobile services, and from American chip suppliers like Intel, Qualcomm, and AMD. Analysts called it an extinction-level event. Nobody expected the company to still be standing 6 years later. Nobody expected it to be quietly taking down Windows in the world's largest PC market. But that is exactly what is happening right now, and almost nobody in the West is talking about it. Just 3 months after the ban hit, in August 2019, Huawei announced something called Harmony OS. At the time, it launched on a television, not even a phone. And critics tore it apart the moment they looked under the hood. It was still built on the Android open source project and the Linux kernel, which meant it was really just Google's foundation wearing a different name. People called it a rebrand, a political statement dressed up as a product. And honestly, back then, they were right. But what almost nobody outside Huawei's own labs understood was that this version was never meant to be the final product. It was a bridge, and Huawei spent the next 5 years quietly walking across it. That rebuild finished in 2023 and 2024 with the release of Harmony OS Next, and this is the version that actually matters. Harmony OS Next contains 0 Android code, no Linux underneath, no hidden dependency on anything American. It was built by more than 10,000 engineers, backed by more than 2,700 patents, developed across 5 years of sustained work most of the world never saw happening. And once that foundation was stable on phones, Huawei pointed the exact same playbook at the machine Microsoft has owned, without serious competition for almost 40 years. The personal computer. Here's the moment that made this impossible to ignore. In March 2025, Huawei's license to use Microsoft Windows expired, and because of the ongoing US sanctions, the company could not renew it. This was not a surprise announcement. It had been visible on the horizon for months, and Huawei had been engineering directly toward it. Just 2 months later, on May 19, 2025, Huawei walked onto a stage in Chengdu and launched the MateBook Pro and the MateBook Fold Ultimate, the first Huawei laptops ever shipped without a single line of Microsoft code running underneath them. Not a workaround. Not a dual boot compromise. A complete replacement. Under the hood sits the Kirin X90, internally codenamed Charlotte Pro, a 10-core ARM-based chip built by Huawei's own chip division, HiSilicon, and manufactured domestically at SMIC on a 7-nanometer process. No Intel, no Qualcomm. It supports up to 32 gigabytes of LPDDR5 memory over a 128-bit bus, delivering roughly 100 gigabytes per second of memory bandwidth. And it's paired with Huawei's own graphics processor, instead of anything from NVIDIA or AMD. On top of that sits Harmony OS Next's own security layer, its own graphics engine, and its own AI assistant, Celia, built directly into the operating system rather than bolted on as an app. Now, is it actually fast? According to testing from the China Software Testing Center, Harmony OS Next boots roughly 32% faster than Windows 11 on comparable hardware, and uses about 29% less memory during multitasking. Chinese reviewers describe the interface as smooth, minimal, and surprisingly mature for a system this young. That said, these are Chinese state-linked testing figures, not independent Western benchmarks, so treat them as the manufacturer's claim, not gospel. Here's the part that should genuinely worry Microsoft though, and it isn't the hardware. At launch, Harmony OS PC shipped with roughly 2,000 applications, a fraction of the 660,000 plus available on Windows. No Photoshop, no Zoom, no full Microsoft Office. But look closer at what was there on day one. WPS Office, China's dominant productivity suite, WeChat, QQ, DingTalk, Alipay. In other words, everything a government office or a state-owned enterprise actually uses on a daily basis. And that order has a name. Jinchuang, China's Information Technology Application Innovation Policy. It's been official government policy since 2019, but the deadlines got teeth in a directive reported in early 2024, instructing every government agency and state-owned enterprise to migrate their computing infrastructure to approved domestic alternatives by the end of 2027. In central government operations alone, this mandate reportedly touches an estimated 50 million devices. That's not a marketing campaign. That's procurement policy overriding market forces entirely. Because when the government controls the contracts, no feature update from Redmond can compete with a directive. The scoreboard already shows movement. Windows held around 82% of China's operating system market back in 2020. By 2025, that had slipped to roughly 79%. And the decline is accelerating as Harmony OS ships on more machines. On phones, the momentum is even sharper. By mid-2026, Huawei's own developer conference confirmed Harmony OS had overtaken Apple's iOS in China, commanding close to 19% of the smartphone market against iOS at around 17%, according to data from Counterpoint Research. Meanwhile, the broader Harmony OS app ecosystem, not just the PC side, grew from roughly 20,000 native applications in January 2025 to over 350,000 by March 2026, backed by more than 13,000 core developers. In December 2025, something happened in a laboratory in Shenzhen that sent shockwaves through the global semiconductor industry. Scientists completed a prototype of an extreme ultraviolet lithography machine, the most complex technology humanity has ever built. This wasn't supposed to be possible. ASML, the Dutch giant and only manufacturer of these machines in the world, had held an absolute monopoly for decades. Each machine costs between $150 million and $400 million, weighs 180 tons, and requires years of development. For context, ASML spent over 20 years perfecting this technology before shipping their first commercial system in 2019. But here's the twist. China wasn't supposed to have access to any of this. Since 2019, the United States had been pressuring the Netherlands to block all EUV sales to China. The export ban was complete. Not a single EUV machine has ever been shipped to China. Western experts were confident.